Hello, and welcome to our section on dimensional analysis. This is an exciting section because dimensional analysis is an extremely useful tool, and hopefully you can understand it so that you're really comfortable with it and you can use it in a lot of different applications in your life. Here we have just a little chart of some very basic English metric and English equivalents. How often have you been doing something and you might like to convert one or the other, either English to metric or metric to English or English to English? English units are not easy to convert like metric units. I'm going to show you a process called dimensional analysis that makes it very simple to convert any kind of unit to any other kind of unit. So let's take a very simple example to start with. We're going to say we have 24 donuts. How many individual donuts do we have? I know you can all answer this in your head, but we're going to walk through it in dimensional analysis fashion. We know, first we must know the relationship between dozen and individual. We know that 1 dozen equals 12 donuts. That's a very important piece of information to know. We call it a conversion factor, a ratio of the two parts of the definition. I realized I misspelled ratio. And it's also called an equivalence statement. 1 dozen is equal to 12 donuts. 1 dozen and 12 donuts represent exactly the same thing. They are equal. It's an equivalence statement. So when we do dimensional analysis here, we start with what we know, 2 dozen. That's what we have. Remember in our problem, 2 dozen donuts. Then we're going to multiply by that conversion factor, the 12 donuts divided by 1 dozen. Now remember, this is an equivalence statement. 1 dozen equals 12 donuts. So in essence, since they are both equal, the numerator and the denominator, we are simply multiplying 2 dozen by the number 1. And we know from math, anything multiplied by 1 is itself. So we haven't changed this at all. We're simply multiplying by 1. And that is this conversion factor or this equivalence statement. Now when we multiply 2 dozen by 12, we get 24. And one really important thing to always remember is that we have to look at units. So here we have a dozen. That cancels out because that's on the numerator and this is on the denominator. And we are left with only donuts. So we have 24 donuts. It's important to always go back, look at all your units, make sure everything lines up and the correct units are canceling out. Now let's look at a little bit more difficult of an example. What if we have 2.85 centimeters? How many inches is that? Well, let's first get out our conversion factor, our equivalence statement. And that is known to be 2.54 centimeters equal to 1 inch. You do not need to memorize these. You can look these up in any table anywhere. The part of this I want everyone to know, like the back of their hand, is the process, okay? So I'm going to give you the conversion factor, and we are going to go ahead and work this problem out. Let's start with what we know, 2.85 centimeters. We're going to multiply by the conversion factor. 1 inch divided by 2.54 centimeters. Now, how did I know whether I would put 1 inch on the top or 1 inch on the bottom? It's a really important question, and in order to answer that, we need to look at what units we would like to cancel out. We want centimeters to cancel each other out so that we know how many inches we have in the end. So we're going to put centimeters on the bottom so it will cancel out with this centimeters on the top. And that is how we decide how to set up our conversion factor or our equivalence statement. I will start to probably use these formats interchangeably, but for now, I wanted you also to visualize and see that 2.85 centimeters is the same as 2.85 centimeters divided by 1. And if this helps you to see what's in the numerator and what's in the denominator more clearly, I'll write that like that for you right now. So I just rewrote this statement here. And once again, I'm seeing that centimeters cancel out, okay? And I can go ahead and multiply across 2.85 times 1 inch and divide the whole thing by 1 times 2.54. When I do that math, I get 1.12, and the only units I have left are inches, and that all works out. Some important things to remember. Units cancel just like numbers do. Another thing, always check to see that your answer makes sense. Does this answer make sense? Yes, it does. If I had gotten an answer of 112 or something, well, no, that wouldn't make sense, and that wouldn't correlate at all in my mind. So always make sure that your answer makes sense to see that you're doing it right. Use sig figs. We just learned about significant figures. Make sure that your answer reflects the appropriate number of sig figs, and it does. The smallest number of sig figs in this problem would be here. We have 1, 2, 3 sig figs. So we can put 1, 2, 3 sig figs in our answer because we're multiplying and dividing. Now here's something really important to note. Equivalent statements are exact numbers by definition. This 1 inch is an exact number, so it does not limit us. So these equivalent statements, these conversion factors that we're using, that 1 inch is equal to 2.54 centimeters, this does not limit our number of significant figures. So what about converting inches to centimeters? We're going to do a very similar process. We have, let's say, starting value of 7.00 inches, and we'd like to convert that to centimeters. We'll use our same conversion factor. And once again, how do we know if we're going to use 1 inch divided by 2.54 centimeters or 2.54 centimeters divided by 1 inch? Well, let's start with what we know, 7.00 inches. We're going to want our inches to cancel out, so we put inches on the bottom with our conversion factor. And here, if we go ahead and multiply this out, our inches cancel, and we are left with simply 7.00 times 2.54, and that equals 17.8 centimeters is what we have left. The term dimensional analysis, in essence, means that we are just changing from one unit to another via these conversion factors that are based on equivalence statements. So that's all it means. It's a big fancy word, but when we talk about dimensional analysis, we're referring to this process. Now, one more example. We're going to do one that is involving more than one step. Let's say we drive 26.2 miles. What is that distance in kilometers? Now, yes, you can go and you can look up the conversion factor from miles to kilometers. Let's say we don't have that, okay? Let's say these are the only conversion factors we're given. We're going to have to do this in multiple steps. We know that 1 meter equals 1.094 yards. We're given that one. We also know the conversion between miles and yards. And we also know the conversion between meters and kilometers. That's just one that you should know in your head. 1,000 meters equals a kilometer. So let's take this in steps. We're going to go from the miles that we know. We're going to convert that into yards, and then into meters, and then into kilometers. And I'm going to go ahead and break it down into 3 separate steps to start with. And if I do that, I'm going to start with what I know, 26.2 miles, multiply by the conversion factor for miles to yards. My miles cancel out, and I am left with 46,112 yards. That is the number that is on my calculator, and I wrote all of them down. Obviously, that is not the correct number of significant figures. When I am doing these different steps, I'm going to go ahead and convert this into the correct number of significant figures. When you do a multi-step problem, you, however, are going to do it all at once. I'll show you how to do that later. And you will write the correct number of significant figures at the end. For the purpose of this problem, I'm going to, since I'm doing this in multiple steps, I'm going to go ahead and take that number and put it into the correct number of significant figures. You may, when you're doing this problem, carry that number all the way through these large numbers until you get to the end and then convert into significant figures. So if I look at my limiting numbers of significant figures, it would be 3. I only have 3 significant figures here. So I need to have 461 as my or 46100 as my number. I can only have 3 significant figures. And I'm going to convert that also into a more useful form with scientific notation down here. 4.61 times 10 to the 4th. Now I'm going to go to my second step, yards to meters, and I'm going to multiply by this conversion factor. The yards to meters conversion factor, and my yards cancel out. So I'm left with this large number now. If I look at significant figures, how many can I have? Well, I have 3 right there, so I can only have 3 significant figures. I'm going to use that in my next step, 4.21 times 10 to the 4th, and I'm going to multiply that by the meters to kilometers conversion factor. My meters cancel out, and I am left with this number, 4.21 times 10 to the 1st kilometer, and I can simply rewrite that. If it's 10 to the 1st, I'm going to move the decimal point 1 place to the right, and I'm going to have 42.1 kilometers. Is that the right number of significant figures? Yes, it's 3 significant figures. I'm limited by 3 significant figures right there. Now, if you would like to solve this all at once, which is much more simple, you can do it either way if you want to get used to this way, or if you'd like to solve it all at once. If I set the problem up by solving all at once, I simply start with what I know, 26.2 miles, and I multiply by each of those conversion factors. Now watch this. I want to make sure my units cancel out in this large problem. It's really important. My miles cancel out right there. My yards cancel out. My meters cancel out. And I am left with 26.2 times 1,760, and that is all divided by 1.094 and 10 to the 3rd. I get 42.1 as my answer, and kilometers are the only unit left. So 42.1 kilometers. An advanced idea, look up some less common units, things that we don't use very often, maybe units you've never heard of. I'm sure it would be pretty easy to find some. Make up your own problems with those. Make more complicated problems with many, many steps involved, and solve those using dimensional analysis. So I look forward to seeing you in class.